Evening, everyone. Welcome back to week 9 from Design to Market workshop. I'm Abigail, your host for the evening, and I'm joined by my co host today, Aidu. Say hi, Aidu. Are you there? Okay. So, we are Women Tech Maker, WTM, based in Ethiopia, and this team is where we grow together by learning from one another. I hope you all had a refreshing break last week. So, guiding us through this data adventure is none other than the brilliant Firi Berhane. We'll be learning more about data analytics and machine learning today. So, grab your notebooks and settle in. As always, we'll be having a Q&A session at the end. And fam, please do mute your mics so that we can have a clear session. Without further ado, let's give a warm welcome to our guest, Firi Berhane. Take it away.
Okay, thank you, Abigail. I'll start by sharing my screen. Is it visible?
Yes, it is visible.
Okay. So this workshop is going to be about data analytics and machine learning. So in this we'll be looking at different topics like the data analytics lifecycle, which contains different steps like data collection, cleaning and exploration, and supervised and unsupervised machine learning, and models that do supervised and unsupervised tasks. Feature engineering and model training. Feature engineering is basically getting all the features of the data ready and making the most out of the features for model training, and model evaluation, which is testing, and business impact. So we do this to in a work setting or in a real world setting. We do this for business impact so that we can know exactly what to do or to gain insights to make better decisions. Okay, so we're using the Titanic dataset in this workshop to go through like the live demo, the code demo, and also just for the examples to go through like the workshop to explain things. So the Titanic dataset is basically has passenger information about who survived and who didn't, and it has different variables like age, the gender, and the fare price that they paid for the ticket, and things like that. So within the data, there are patterns that sort of reveal who survived and who didn't. There are correlations within the data, and we'll be exploring that. So diving deeper into the data analytics lifecycle, the first step is collection. So in the Titanic example, we already have the data. Anyone can find this through Kaggle or on the internet. So that's the easiest step. But in a real world setting and like jobs or when we need to collect data, we can do web scraping and we can get it from reports. It could be structured or unstructured. And structured data meaning like in Excel files in CSV with like the columns and the attributes defined, and unstructured data being like videos or just text files and things like that, documents, things like that. And after we collect the data, we get into cleaning. So when cleaning data, since it usually comes from like different sources, we have to make it uniform. And also there usually is like missing values within like data that's gathered. So those missing values either have to be replaced by representative values, or like removed altogether. And we have to handle outliers. If anyone's familiar with outliers, it's basically data that's outside of the normal range of um, a certain attributes values. So these have to be handled and dealt with. And then we have to do exploration. So exploration means like exploring the patterns within the data, and we can do this using graphs. And there are several different ways in like pandas and like programming that we can do. We can explore the data. Okay. Any questions so far? Anyone? Okay. So to give just an overview of like what the Titanic dataset looks like, here we can see like the name, the gender, age, and like parch here means whether there are parents and children involved, and sib SB is like spouse and sibling. So and like the fare, the price that they paid to get on the ship, and things like that. So this is an overview. And uh, here like we already have the data. So in cleaning, we can see here non values. Non means not a number, right? So we can't feed columns or attributes that are missing, that have missing values, or that have nonce. So these have to be like replaced with representative values, or they have to be removed. And also here it's male and female, but we can't train a machine learning model directly without with these categorical variables, like with these words. So it have to be encoded with numbers. So things like this, and if there are missing values, those missing values have to be either replaced or they have to be removed. And some of these variables, like the passenger ID or the name, these things don't matter when trying to predict who survived or and who didn't. So some of these values also would be replaced when it comes to building a prediction model around this data. Yeah. So and when handling data, we have to consider several things, like what's the distribution of the data. Like if it's a continuous numerical data, uh, does it have a normal distribution? This is what a normal distribution looks like. It doesn't skew, or it doesn't skew to any side, like doesn't have a negative or a positive skew. Here, negative skew, like it has a longer tail to the left, and a positive skew has a longer tail to the right, meaning that most of the data is on the right side in a positive skew, and in the negative skew, most of the data is on the left side here. So within the distribution or the range. So these things have to be considered when picking a representative value, when, let's say here, when we're like replacing when we're replacing or when we're handling missing values, uh, like we said earlier, that the age would have to be the variable, like whatever variable is missing, like let's say for example if it's the age, the we can't use the average if it's a skewed type of distribution, like if it's a negative skew or a positive skew. We use the mean or the average when it's a normal distribution, when it has zero skew. So we have to consider these things. And if it's a categorical variable like here, male and female, and if there are missing values, we choose the most frequent one. Like for example, if the number of males that were on the ship is greater than the number of females, then the missing values would be replaced by the with male. Like so we would assume that they were male. Yeah. If any of you guys have any questions, please ask. So here we get to the like machine learning part. That was the data exploration and cleaning and the collecting part. So here in the machine learning part, most of you would be familiar with supervised machine learning and unsupervised machine learning. So basically, supervised machine learning is when the sorry is when the predicted variable or like the target variable is present within the training data. So here within this example, this specific example, the Titanic data set, the target variable is already available within the training data. Here we can see survived. The survived variable is already present. So yeah, in supervised machine learning, the input would be would be like the just the features and the target variable. Together, we can predict the outcomes. We can train it on the labels or the target variables, and then after it's trained, it can predict just with the input values what the labels could be. And an example of this would be like the classification and regression. And the classification and regression is predicting these variables, the target variables, when the target variables are numbers. And the classification is when it's categorical. Like in this specific scenario with the Titanic data set, the outcome is like to determine whether like the passenger survived or not, right? So we're making a decision here. So this is a classification problem, and regression would be like, let's say, to predict a continuous variable like a number. So it could be what if we have certain data that could predict like the temperature. So that would be a regression problem because temperature is a continuous value. And in unsupervised machine learning, there are no labels. So the task is to discover structure. If anyone's familiar with like clustering, um, is to the task is to like cluster or group data based on like their similarities. And yeah, so feature engineering is selecting like the most important variables and also normalizing data and scaling. Scaling is basically some data, like for example, here here like the age could go up to like 100, but maybe only 2 or 3 people are in the elderly group. So that could really influence the data because the machine learning models, just if it's a large number, it could really impact the value, or if it's a very small number, it could also really impact the value. So to make the impact of all the variables, or sorry, to make the impact of all the values the same, or like comparable, we have to scale data and also like normalized data. Normalized meaning like we have to make it like this, have a normal distribution curve. So yeah, selecting key features, also making other features out of key features to model the data well. Modeling meaning like to create a model that can predict future outcomes. And so feature engineering includes transforming, encoding, and scaling. And model training, we split the data and into training data set and testing data set. And the training data set would be used to train the machine learning model, and the testing would be used for evaluation purposes. So there's a lot of algorithms, like even in classification and regression, like decision trees and logistic regression. There are several others. So for the purpose of feature engineering is to transform the raw data into meaningful features that the model can learn from, that the model can take more insight from. So we have to select relevant features and keep or derive features that may relate to survival. For example, in this Titanic dataset, like for example, here in the data, we'll get to the coding session, will be more clear when we get there, but we see here that this is parch means a parents and children, and this means siblings and spouse. So basically, if it's one, it just means no, the person only brought like one spouse or one sibling. If it's zero, they just came by themselves, and things like that. So if we want to know like how many people came with a certain person, we would add these two values up. And that could be important to know because, you know, the ones who had more family could have been left behind, for example, because they were helping the others out, or they would have like helped each other. All of them could have helped each other so that um, maybe most of them survived. So there are certain patterns like this that might have affected their survival. So we can create features that might be important for guessing, or sorry, predicting who survived and who didn't. Yeah. So also we have to encode categorical variables, like we said, with encoding like the male and female. Otherwise, we can't create a model and train a model out of this. Okay. So types of supervised machine learning. So yeah, there's logistic regression, has a binary outcome, and decision trees. Decision trees are basically like flowcharts. I think here most of you are like familiar with flowcharts. So basically, we make decisions with flowcharts, right? Like we make yes and or no decisions. So basically, that's uh, that's how this works at the basis. This is how decision trees work. They have different nodes that decide whether uh, it's a success or not. And based on that, finally it decides on the final node what the value is going to be. And a random forest is basically like a collection of these decision trees. And so that like the decision of each decision tree would be taken into account, aggregated, maybe averaged, to get the final result or to get the final prediction. That's what a random forest is. And can then here it's unsupervised machine learning, and it finds patterns from nearby data points, meaning like if there's a small distance or similarity in the data points, they would be clustered together. Does anyone have any questions here? so far? Is everything clear at least? Okay. Okay. So yeah. Um yeah. So random forest, we can see here like different decision trees. So we get each of their results and uh, just think of it as voting or averaging, and we get the final predictions from all the results. Sorry. So when we evaluate a model, like after we train it, there are several matrices that we need to consider. So accuracy is like the most common one, and the one that most people are familiar with. But there are as equally important model evaluation matrices like precision, recall, F1 score. So accuracy is basically like how often was the model right? Like in actuality, since test data also has the actual labels, but when we do testing, we don't give the actual labels, right? It just predicts the labels, and we have the actual labels since we reserved testing data, so we can compare uh, which ones are right and which ones it predicted right. So uh, when we compare these two values, if how we get the accuracy is uh, we use the ones that are predicted as correct or as a success, and the ones that are actually a success, and we compare them. And so basically, that's how we get it. And yeah, precision is when we ask, when the model like said someone survived, how often was it correct? So that's what precision is. And like recall is like uh, uh, how many positives, like how many of the positives that it predicted are actually correct. And F1 score is like a balance between the precision and the recall. So yeah, all these values are very important. And yeah, so like I said earlier, it's accuracy alone isn't enough. There are times when precision is very important and times when recall is very important. So we have to evaluate all these things. And when we go from like when we try to make like business decisions based on the results that we have, um like there are different, like we don't just train models just randomly. We have certain goals, or we have certain things in mind. Is it to reduce risk, or is it to save money or time, and or also just to just report based on what the stakeholders or business people want to know, to just report. That could be the goal. Or we could have like concrete goals like reducing risk on something. Like in this example, the Titanic data set, the business goal is like let's say you're working as a data analyst in some shipping company. So maybe this type of the predictions, or like the model can help with assessing the risk based on like the age, or which class they are in the boat or in the ship, or how much they paid, things like that. So yeah, needs to have meaning. Okay, let's go to the practical. Does anyone have any questions? before we go to the live demo, to the code demo? Okay, everything is clear so far? Okay.
Yes.
Okay. So,
Yes, madam. Are you hearing me? Hello?
hello?
I think
Yeah, I have a question for you.
Okay.
Regarding the model evaluation, I just a more clarification, maybe something, I missed something on the model evaluation, and it could be better if you explain it more.
Okay. Okay. Which parts exactly? I'm sorry. Oh,
Okay.
which part of the model evaluation?
Uh, if I didn't miss, maybe regarding the Canon model evaluation. Mm.
Okay. Regarding what? Sorry.
Canon, Canon machine learning model.
Okay, and then okay. Sorry. Okay. Okay. So Canon is we didn't really cover it here because we're more focused on supervised machine learning. So when it comes to evaluating like these unsupervised machine learning, uh, so it involves like assessing the performance of the algorithm, and we use the evaluation matrices here, like the accuracy, the precision. We call like all of these. We use it. We use all of these, and also we also you can use cross validation, and we can do like all the things that we do for like these models, the supervised models, and yeah. Is it clear?
does that answer your question? Okay, I think it's clear.
Sorry guys, by the way, I have a flu.
It's fine. It's very fine. If you want to take water, you can.
Okay.
You can do
I'm actually drinking water.
it.
Okay. Okay, so yeah, we need certain libraries like pandas, numpy, seaborn for visualization, and matplotlib also for visualization. And with pandas we can clean data, and with numpy we can change the type and things like that. So we usually, these are standard libraries that we use when dealing with like data analytics and machine learning. So here we have our training data and we have our test data, and we can start exploring the data here. So the length here is 891, but as we can see here in the info, not all of the values are present in like all the rows or like all the data points. For example, age only, there are only 714 recorded values. The rest are empty. And cabin, or the room that they were in, also there are a lot of values that are missing. Usually when there are a lot of values that are missing, it's considered unimportant, so it's usually dropped, wouldn't be important in the analysis. Or if the values like actually essential for the analysis, or like in predicting whatever variable there is that we need to predict, we have to collect it. Usually when it's this small, we can't use it. Okay, so here I've divided this into numerical variables and categorical variables. Here the numerical variables are age, siblings and spouse, parents and children, and fair price. Fair is like the fair price, and for the categorical variables, survived is a categorical variable, and the gender, and like cabin, which room they were in, and things like that. These are the categorical variables. And here we can, like, when we visualize the numerical variables, we can see certain patterns. Like here, in the age, um, there are a lot of people in the 20s and 30s age group, and the 70s, and the people in their 70s and 80s are actually like uh, very small in amount, and yeah, almost in like the outlier category here. And here, siblings and spouse, we can see that most people just bought one sibling or one spouse. Most of them actually didn't, just boarded on like by themselves. Here, zero. We can see zero means just that one person. And parents and children, same thing. Most people didn't bring anyone, but if they had to, just one or two people. And fair price here, as we can see, the people, most people actually paid very little, the low fair prices, meaning that they weren't in like the first class, or the expensive class. They just paid the low prices. Yeah. So yeah, here there's P class and there's fair. P class means like like first class, second class, and things like that. And hue like the orange and blue represent whether they survived or not. One, most of the times, usually means they survived, and zero means they didn't. One, since it's a positive number, think of it that it's a success, and zero is uh, the failure or something. So yeah, so as we can see, the ones that are in the higher classes, like the first class, and the ones that paid a higher fare, actually survived more. We can see here. Yeah, it was, as we can see here, this is the fare, and this is the P class. So the ones with the higher fare and the class had a higher survivor rate, because they had more accommodations and more tools, like the boats were closer to them, and uh, and we can basically see the story here, like the data itself, even just with the graphs, it explains a lot of things. So that's usually what we should be doing when we're trying to explore data. um, we can create it like a story around it, basically understanding the data. Even right now, we actually have gotten like a lot of insight about the data. And yeah, so this is what we should be aiming for. And here we can make a pivot table, which basically takes like the average or like the aggregates of the people that survived and didn't, the ones that didn't. These are the numerical variables. So here we can see like uh, the ones that survived were like on average just a bit younger at age 28, and the ones that didn't were a bit older, but this doesn't show much difference, so we're not really going to take it into account. But in the fair price here, we can see that there's a lot of difference. Like almost when we subtract these two values, it's 20, 26, right? So the ones that paid a larger amount survived more, as we can see here. And parents and children, these things don't really have a lot of impact or a lot of difference as well, as we can see here. So they probably don't have a lot of impact on like who survived and who didn't. Okay, so here bar plot for the categorical variables. So a lot more people didn't survive, as we can see, and there were more males than females on the ship, and yeah, things like that. Embarked. These are, I think, like the different classes in the ship, and this also looks like it has a meaning or impact on the survival rates. So yeah, we can make a pivot table out of the categorical variables as well, and we can see patterns of these things. Like for example, here in P class, on average, like a lot more people survived that were in the higher classes. We can see in the first one. Actually, the third class, or like the lowest class, also they survived. So the ones in the middle didn't survive mostly. So we can see these types of patterns here. Very important patterns to recognize. So yes, when we come to cleaning, first we have to see which of the variables have empty values. Like here in age 177 of the passengers don't have their ages recorded. And you can see in here too, like the cabins or their rooms also weren't recorded. So we drop the values that we don't think have any importance when it comes to predicting whether the passenger survived or not. So yeah, in the training data, we drop these values, and age, we fill it with the mean because as we can see, it's just 177 values. So it's not a lot. If it was a lot, we just drop it. But since it's not, we fill in the missing values with the mean. And since embarked is a categorical variable, we since embarked is a categorical variable, we choose like the mode, like the most frequently present value. Yeah. So feature engineering, in the slides, if you remember, it included like normalization, data normalization, scaling, and transformation. So basically, very often like right skewed, that meaning that most people paid lower fares, and only some people had to pay like the high prices. So we don't want it to create like long tails, since this would impact the machine learning model. Basically, the machine learning models are like highly mathematical, and if they're impacted with unnecessarily by large ranges, with just few values, large range with just few values, we don't really it would create bias in the machine learning model, and that's why we have to normalize the fair in the training data. So we normalize it, and here in the distribution, it has like a normal looking tail, like there's nothing too skewed here, as we can see. Anyone have any questions so far? Does anybody have any questions? Okay. Okay. So yeah, this is a heat map, and we can here we can use the numerical values and see if there's any relationship. And one meaning there's a huge relationship. If it spans down to like the negative, it means that it has a negative correlation, and if it's 0 point up to like 0.6 to 1, positive correlation, and within these values it's like neutral, not much correlation. So uh, these things would also be very useful when it comes to like knowing the survival rate, because here we even have the survived we have like the data on who survived and who didn't, so we can see like the correlation here. Okay. So also when we train such like a machine learning model, we have to encode like values. Like for example, if it's male and female, it has to be 0 and 1, and embarked 2, it has to be encoded. So encoding means like if it's male and female, male can be 0 and female can be 1, things like that. So that has to be adjusted in the training data.
Excuse me if I interrupted you. I think Rama had a question.
Okay, please go ahead.
Is Titanic an app to run Python? That's the question.
Um, so is Titanic a what question? Sorry, again?
Is Titanic an app to run Python?
Okay, oh yeah, yeah. Like if you're looking for it, you can find it on Kaggle. There's a data set on Kaggle. You can find it there. I think that answers the question, right?
Yes. Yes.
Okay, okay. Thank you. Okay, so here now we've defined a uh, we have defined a classify function, and we can fit a model here. So we have to pass in the model, and the test size is here like 25% of the data, and this is a random selector. So like the data is like rearranged randomly. So so that it doesn't, when it iterates upon like training, it doesn't, the order doesn't actually impact the pattern that it finds. That's why we need to change the order randomly when training. So here we have a decision tree classifier. We can train, and here we have an accuracy of 76%. I mean, like, the 76% is not that big of a score, but if there was more data and better data processing cleaning could be higher. And there's this classifier LGBM, and you can also use that here. The accuracy is better with this model, so it's better. It better captures like the pattern in better captures like the pattern in the data. This model and the random forest classifier, which is like the ensemble of the decision tree models, we can see this is also for better accuracy. It's 81%, so for better accuracy. Extra trees classifier, yeah. So we also have a logistic regression model, and okay, it has a NaN value. Okay, so sorry. So yeah, and now we can test it with a test value, and we'll also have to like make the test data go through all the pre-processing that we made the train data go through to do this. So it has to be pre-processed, and yeah. Let's use this one. Yeah, so we can aggregate this to know which what the accuracy is and things like that. So yeah, that's it. Does anyone have any questions? Okay, thanks everyone. So no questions.
I think Rana asked it again. Will there be more session as such?
Okay, so on machine learning, I mean, like we haven't planned any other session, but that could be something we can consider in the future.
Yes. Okay. So does anyone has question? Okay, until then, I have a question. So more of a general question. You're you're talking we were talking more about data analytics, right? So as in generally people say it's hard and I am a beginner at the course. So would you share your experience as a data analytics? Is it really hard or any tips you would give us in the learning?
Okay, so no, I wouldn't say it's hard, but what I sort of struggled with at first was all of the data that I found on the internet was just a bit simple, you know. It was in CSV files, Excel files, and was almost already clean, or you know what to clean, and that's not always a good thing. Um, uh, so what I would recommend is try to get like try to collect the data yourself and do these steps, because that would create more meaning.
Okay. Does anyone has any other question? Okay, I think I do have a question.
Okay. So data analytics is usually about exploring the data. Like if you guys have noticed, I've actually made a distinction between the data analytics life cycle, which contains the cleaning and the exploration and gaining the insights, and collecting the data and stuff like that, and then the machine learning part or the data science part, where that includes creating predictive models to predict certain variables or to make decisions on certain values. So basically, data analytics focuses more on the data collection, cleaning, and the data collection, cleaning, and exploration, and generating reports and insights and things like that. While data science usually involves creating predictive models, machine learning models, and shaping models based on the data that we have. Is that clear? Okay.
Okay, I think Naomi has a question. What type of project would you recommend for someone who wants to practice machine learning?
Mm, well, I mean, like, you know, it depends on what part of machine learning you want to practice. But if you were to ask me, I would say like RAGs and building AI agents and things like that. So right now the trend is not just a trend, but most things have been possible, and most people might not even need professionals to handle these things like the data science and exploring insights and data and things like that. So I would say like working on building AI agents and working on RAG chains and like make the communication of AI agents and connecting them, things like that. Agentic I would say right now is a good place to explore, good thing to explore. Does that answer your question, Nami?
Yes, Naomi said yes. Okay, any other questions, guys? Okay, one last question for me. I hope to ask more questions, but aside from the time we have, what would you say you had the most challenge what, on your learning journey?
On my learning journey on machine learning, the challenge, um, it was at first like getting real projects, like I said earlier. But like when I got to those projects, basically guidance. I think guidance was a huge problem at first, uh, because most people were focused on maybe front end or back end and web development and things like that. And I couldn't get a proper mentor or proper team that was working on machine learning. So that was what I found difficult at first. So I think the best way to to solve this problem would be like to get into maybe hackathons and just get mentors, try to get mentors. I think that's the best thing to do. Okay. Another question? Do you have any other question?
Let's wait 1 minute if you guys have any other question. Okay, I think our members don't have questions. That was such a great session. A big thank you again for Firi for joining us and giving us this valuable insights. You learned so much from beginning from meeting the data, purpose of featuring types of supervised model evaluation. We've learned a lot, and we even practiced using data tools. So thank you so much for joining us and taking the time to share this lesson, even though you were a little sick. We really appreciate you being here. Guys, can you make a noise? Come on. Noise, applause. Yay. Yes. Thank you so much, Fury.
No, thank you for having me. It was my pleasure.
Okay.